Welcome to Session 15 of Grade 11 Advanced Algebra and Precalculus. Today we study complex numbers and conjugate roots. The focus is to solve complex root quadratics and use conjugate pair structure. By the end, you should be able to do these three things. 1. Use I for square roots of negative numbers. 2. Solve quadratics with complex roots. 3. Apply the conjugate root theorem. Complex numbers appear when an even root tries to take a negative value. They are not a failure of algebra. They complete the number system, so equations like x squared plus 1 equals 0 have solutions. The imaginary unit I satisfies I squared equals negative 1. Solve x squared minus 4x plus 13 equals 0. Using the quadratic formula gives 4 plus or minus the square root of negative 36 all over 2. The square root of negative 36 is 6i, so the solutions are 2 plus or minus 3i. If a cubic with real coefficients has roots 5 and 1 plus 2i, then 1 minus 2i must also be a root. The complex pair multiplies to x minus 1 squared plus 4, which keeps the final polynomial real. Your turn. What is the conjugate of negative 3 plus 7i? Pause the video and solve it. Here's the solution. Work line by line, then check the final answer against the original question. After the video, complete these three tasks. Copy the model from the lesson, solve each one fresh, and write one error log sentence about the mistake you are most likely to make. Let's recap. I squared equals negative 1. Negative square roots become multiples of I. Complex roots often appear from the quadratic formula. Real coefficient polynomials have conjugate non-real roots. Before moving on, write one sentence. The step I must protect is that small reflection turns the video into real self-learning.